everyone, and welcome to today's Open Teams community event. I'm Brian Skin, the Open Source Architect Community Manager here at Open Teams, and I'll be your host for today. Open Teams is the single point of contact and procurement for expert help to address your open source training, solutions, and support needs. Visit openteams.com or reach out to us at connect@openteams.com to learn more. As part of Open Teams' overall mission to sustain and support open source, we are also sponsoring the Open Source Architect community, with the goal of providing a dedicated space for experts to connect and collaborate over their favorite open source technologies. To learn more or to apply for membership, visit openteams.com/OSA-community. In today's event, I'll be talking to Chase Millian, founder and CEO of Millian Concepts, a research and software consultancy with deep technical expertise and a strong commitment to open source. Chase and Millian Concepts have executed a large number of space and astronomy-focused projects, and that is cool, and have a deep background in handling the data needs of these situations. Counter to what you might expect, though, they've not found that these data needs to be all that exotic. They're more similar to terrestrial projects than you might think. Today, Chase will be sharing about what he and his team have learned about data, what sorts of needs you face, how to think about them, and how to design and implement solutions that successfully meet those needs. Thanks to everyone for attending. Please add any questions you might have during the conversation into Zoom chat or Q&A, and we'll address them as we have the opportunity. We are recording today's event, and that video will be posted on the Open Teams YouTube channel once it's ready. Subscribe there to be notified when it goes live. All right. Hey, hello, Chase. Welcome. Thanks for being here.
Hi, thank you.
We actually, in this virtual world, we actually had the opportunity of meeting in person earlier this year at PyCon. That I really enjoyed that opportunity.
Yep.
So to get started, tell us a bit more about yourself. What's your background, education? How did you come to be in software and space and scientific research?
Sure. So I am the founder and CEO of Millian Concepts, which, as you said, is a consulting company. We do open source first development, mostly in support of research in academia, although all organizations do research of some kind. My background is I'm knocking on 25 years of experience doing this sort of research support, software development. Long before research software engineer was a job title, it was the thing that I was doing. It started around 2002 when I was an undergrad in physics at Cornell, and I wanted to be a particle physicist, but I also needed a job. And a guy named Josh Soldickstein offered me a job at a party, and I went and found him in his office the next day. And it turned out several months later, I didn't realize it when I took the job. Several months later, it turned out that we were working on calibrating the cameras that would go on Spirit and Opportunity and would launch in just a few more years. So it was not from the beginning my goal to work in space science, but once you start doing it, most people catch the bug pretty hard, as I did. From there, I went to Caltech for a few years. I worked on a mission called GALEX, an ultraviolet telescope, which the data for which I still work on sort of 15 years later, we're still extracting new value from that data. And then as that mission was winding down, I decided to start my own software consulting company. There were just a lot of things I'd seen over a couple decade and a half about the way that software development was being done in academia, and I thought I could do it better. And I thought the best way for me to try to do it better is to strike out on my own, where I would have actual control over things and not be beholden to an existing structure of how things are done. So that was 15 years ago now. And we're steadily growing and continue working, and I'm very proud of the tremendous amount of work we've done. And I think I've proven my thesis at this point that there was a better way to improve research software. A lot of people are joining from different from perspectives, joining the realization that this is something we need to focus on. Has a lot of value.
Yeah, including, I mean, I know a couple of different people who now are, like you said, the title research software scientists or whatever, where they are at academic institutions, but they're role is to provide the software support to the other research that's happening in those institutions. So it's kind of
Mhm.
another angle on that.
Yeah,
Um,
it recognizes a position now, which is great. It's sort of recent that that's the case. And
mhm,
when it was something I wanted to focus on, it was sort of technical staff was the best you could get as a
mhm,
recognition that this was a real role in research. So I'm very happy that the position is being professionalized.
mhm. And being put at a level where it actually is a long-term career path, not just a support role. It seems like.
Mhm.
Yeah.
Yeah.
So you don't Million Concepts does a lot of space and astronomical work, but that's not all you do, right?
Um, I mean, it's where most of our business has been,
Mm,
with any consulting company, especially when you're starting, it's sort of personal networks of the founder is how a consulting company grows. So my personal networks are in space.
okay.
Um, the I will say the problems we're solving, so some of them are esoteric to space. There aren't a lot of uh, enterprise applications for calibration of planetary robotic images. Um, Although there will be an increasing number of those opportunities, as with Viper, which is a partly commercial mission. Um, but a lot of the problems we face are familiar to commercial non-space enterprise customers. It's how do we manage this 400 terabytes of data in the cloud and process it correctly so that we can get the one or two pieces of information out of it that we need so that we can make actionable decisions on human timescales that
Yeah.
don't drive the project or the mission in the wrong direction.
Mhm.
Um, they're the same problems. We end up using the same technologies. In some cases, we end up pushing the boundary on those technologies, like LSST, the Large Synoptic Survey Telescope, which is under development now. It has, I'm going to get the number wrong, but it's something incredible like a petabyte a day of data that it has to deal with.
Yeah.
So even on the scale of Uber, this is a lot of data. And new technologies have to be created to deal with those. And then inevitably, a few years later, other sources of commercialized data become available and they can leverage those technologies.
Yeah.
I think our so after I worked on Galax, I worked on a software tool called Gphoton, which took the Galax data and recalibrated it
Hmm.
so that we could continue to extract more information out of the Galax data. The Galax data at the end of the mission was about 130 terabytes
Wow. Okay.
raw, which is not a amount of data now, but in 2008 was an incredible
Yeah.
amount of data. Um, and I believe this was never confirmed. It's not in any list, but I believe at the time we released the database of those events that it was one of the 10 largest public facing databases in the world.
Mhm.
And when we turned on the server at the Space Telescope Science Institute, it locked up their firewall because it looked like a DDoS attack. um, and yet all of that experience now has served them and others in preparing for the next waves of data. JWST is a huge amount of data
Oh yeah.
compared to Galax.
Mhm.
TESS is a huge amount of data compared to
Mhm.
Galax.
Yeah.
So
Then you have ground bound, like all the particle accelerators, and I think from what I understand, like a lot of the fusion systems that are experimental fusion systems, once those get scaled up, they're going to be having extremely large data streams also.
yeah, I bet. Yeah.
So so yeah, I think now the way we talked about framing this was to start out by so you touched a bit on capacity and bandwidth and those sorts of things and similarities between enterprise apps versus space and scientific research. Let's touch on some of the various considerations, the metrics that you have to think about when you have a data challenge that shape how you have to craft your solution so that it works the way you need it to. So capacity and bandwidth are the one that I think a lot of people go to. It's like, oh, big data. But from what we talked about, in prep, it's not just size; it's also various aspects of robustness and reliability. So maybe pick where makes sense, whether data integrity, uptime.
Yeah. Let give me just a second to frame this in my mind.
Mhm.
So kind of the thing I wanted to talk about, which I thought might be interesting, is when we approach a new data management problem on one of these missions, and Viper is the most recent one that we've worked on, and Perseverance slightly before that. There is a tendency to want to sort of throw existing technical solutions at the problem. So in the case of Viper, we to provide some context, we're working on the Viz imaging system. It's 8 cameras. They will be positioned around the rover over the course of the mission every few minutes, maybe a few times a minute.
And
These
this is
cameras.
the Moon South Pole surveying.
Yeah. Sorry, but so Viper is it's a lunar rover, CLIPS mission. The lander is being built by Astrobotic in Pittsburgh, and the rover is being built by NASA. It will go to the south pole of the moon and visit the permanently shadowed regions there. But it's a solar powered rover, so so it has to be in the sun so the batteries can charge, and then it will dip into these permanently shadowed regions where we think there may be water ice in the regolith. And then it will leave the permanently shadowed regions and get some more sun and dip back into a permanently shadowed region. Because it's on the moon, unlike for the Mars rovers, where there's a 30-minute delay at best between when you send a signal and when you receive a response, on the moon, it's basically instantaneous. It's like half a second or something.
Sure.
So Viper will be essentially joystick driven. I don't know the exact control panel layout, but there will be a human who is actively controlling the rover in basically real time.
Mm-hmm.
And to aid that person, there is the system of 8 cameras that point all around the rover and provide a visual context for the rover. Being that they are cameras, they also have scientific utility, obviously. The geologists want to look at them. The engineers want to look at them. So we're developing a pipeline with Ross Bayer at the SETI Institute to manage this stream of data down, calibrate it, extract other sort of metrics and information from it, serve that to the team, which will be sort of actively monitoring all of the data, including the pilot of the rover, and also take requests from the team. So if we see out of the corner of one image, oh, there's a fancy rock, we would like a better picture of that rock to give the scientists a way to say, I want to, if we get the opportunity, better picture of that rock, please.
Flag features of interest.
Yeah. And then also track, oh, we got that picture of the rock, so we can take that request off the list. So this is in terms of like a data interaction workflow. It's really not that exotic. It's something like you log onto a website and you request a service, and the service arrives, and there's sort of round trip tracking of these things, and it goes into a database.
Mm-hmm.
So we had a temptation when we first started this to manage all of this workflow with sort of off the shelf enterprise solutions. And the thing we first thought of was Airflow or Dagster, and this is just to manage all the operations. You get a data signal, the data has arrived. They need to kick off multiple processes. You monitor those processes. This is what Airflow is for.
Workflows, totally.
Yeah. But I think that could have worked. But we've sort of learned, and I've sort of learned from years and years of doing this, that the organizational and social aspects of the technology that you're putting into the project matter a lot more than we'll say the legacy of the technical solution. So where I think we provide value as an organization. That's something I pride ourselves on, is that everyone in my organization takes the ethnography of the team that we are working with very seriously.
Mhm.
And we try to understand the context in which the software will be operating socially. And one of the things we discovered, there were a couple sort of red flags with Airflow as a solution. One of the things was the Airflow can be quite complicated, and the environment in which we're going to be operating this system is 24 hours. Someone will have to be on call in case something goes wrong for the whole duration of this mission. And it's possible, although this has not been, this sort of thing is in flux, it's possible that the security infrastructure around operating the mission will mean that at best, our technician can only get an SSH connection through a terminal into the entire system.
Mhm.
So we need to design a system. We need the system that could be managed in that way by one person, even sleep deprived at 4 a.m., who might even be a junior person. If we're now, 4 months into the mission, I'm not going to be staying up every night working on it. So for that reason, we did a whole trade study. We looked at all the extant solutions, and we decided, sort of against what our initial better judgment would have been, that we should home roll a data management system rather than going with something like Airflow or Dagster or any of the many other possibilities, and actually design it for the environment in which we would be working. So
Mhm.
this is a thing. It's built off a tool set that we produced previously called Hostess, which is it's sort of our internal PowerShell at Million Concepts. We use it to manage our AWS deployments, but it does all sorts of powerful networking things. And we've extended it for this project so that now it has this this graph management sort of capability. It can be monitored over a SSH terminal, and most importantly to me, sort of socially, is that everyone on my team will have complete understanding of the entire code base. So
Mhm.
if something goes wrong at 4 a.m, 3 months into the mission, anyone who might be in our hot seat will be fully qualified and prepared to handle the situation, and we won't have to worry that it is some error deep in the guts of Airflow that hasn't shown up on a Stack Overflow post and
Mhm.
lost.
Or that you can't wait for a GitHub ticket to get processed and a PR through.
Yeah. And there were other considerations, which is Airflow is it's really designed for the cloud, and we're not going to have a cloud. We're going to have a single server. It's going to be very 1985 in terms of our network architecture. There's going to be a single server that manages our thing, and everything runs on it. It'll be in a container, which is a relatively, a newer technology, but fundamentally the cloud won't be present. And also the rate of data throughput is so small that we're not worried about managing the flow as much as we're worried about having visibility into every single data point that's running through. Like it's such a slow amount of data at times. We expect maybe one picture a minute or one picture every 5 minutes. It's a small enough data flow at any one time that the technician could actually just monitor the data as it passes through the system. And we want that insight into the system. Another thing that we've learned from these projects is that once we land, another thing we've learned from space projects, we'll say, is that once we land sort of within the first 2 weeks, a lot of the ideas about what we would see and how we would deal with the information that we're getting down will change very, very rapidly in those first 2 weeks, because every time you land somewhere for the first time with a new suite of instruments and a new team, people have different ideas about what is important and how they want to work on different things, and you have to adapt very, very quickly to that, especially in the first few weeks of a project. And this is only it's a 3-month project at most. The mission is time capped on account of the sun will set on the south pole of the moon. So we don't have the time to either have data downtime or to take a lot of, we can't take 3 weeks and develop a new workflow for the team, because they're going to be operating 24/7 through the whole mission. So we needed something that was very simple and flexible and that we understood completely. So that's the thing I wanted to talk about. I don't know if you have many more questions about that, but
So I guess I think I'd kind of step aside and ask
yeah,
about it kind of in the context of some of the other work you've done.
yeah.
So obviously it's a very different set of considerations from the the massive terabytes data sets. And I'm coming into it, I'm sure you knew that from the early briefings on the project.
Hmm.
Um, how I think what I'm wondering at the moment is what was the process like as you both internally with the team and then all
Hmm.
in just the Million Concepts team, and then also interfacing with the broader team. How much of that was obvious? How many of those needs were obvious from to you from the outset? Oh, we need to think about this. And how many of them kind of emerged over time from conversation internally and externally?
Hmm. Um, yeah, so how it worked on this project is very similar to how it has worked on other projects, including Perseverance, where we work on the Mastcam Z, the mass-mounted camera system, um, which is that when we were brought on, there was sort of a specific broad category of problem that we were intended to solve. In the case of Viz, on Viper, it was this orchestration of the data flow, management of the data flow, the request system, um, managing the point-to-point monitoring that
Hmm.
requests are being fulfilled and
Hmm.
correctly. In the case of Mastcam Z on Perseverance, it was to help with the multispectral science generally. So the Mastcam Z cameras have multiple filters, and they take
Hmm.
images through different filters, and then you get spectra. And there's a team within Mastcam Z who look at those spectra, and they had legacy tools, and the person who hired us, Melissa Rice at Western Washington, knew that there would be emerging needs. So we were brought on to just sort of help. Um, in both cases, there was sort of a broad problem, which is that this could be better, or this needs, this general problem needs to be solved. And then also in both cases, we intentionally took the time and made active efforts to learn as much about both the technical and the social aspects of the project as quickly as we could,
Hmm.
and then um, identify specific things that we needed to keep in mind. So these would be like unwritten requirements.
Right.
So sometimes you have technical requirements that flow down clearly in a document, with IEEE branding on the front and all of that stuff. Many times, probably in all projects of any complexity, there are a lot of other requirements that everyone knows are requirements, and they are not written down anywhere. And especially when coming into a new team, when we came on to Mastcam Z, that team had been working together in one way or another for almost a decade at that point,
Yeah.
preparing the project. And I think we formally joined a week or two before landing.
My gosh. Wow.
So, Viper is much better. We have much more runtime. But in both cases, it's really important to us that we understand the full context of what we're doing, that we don't
Yeah.
simply take, here's a top level requirement, execute on that with no interaction
Hmm.
with the environment in which we deploy and um, the people will be using it. So we send a lot of emails. We do a lot of extra outside research. We definitely draw on past experience on projects of all kinds. So my business partner, Michael St. Clair, he has a background. His PhD is in performance studies from Stanford, where he did ethnography, which is incredibly useful when you're trying to understand the social system of a team.
Mhm.
And he also did theater and sound design. So if you want a model for a crucible of high stress, under supported, bad lines of communication, but the project must execute no matter what, the show will go on no matter what,
Yeah.
then theater is that. So we draw on all of our experience, and we do as much research as we can, and then we try to identify, okay, here's the problem statement as it was handed to us. Sometimes vaguely, as in, I don't know, help. But then what are the major pain points of the team? Which often anyone who does like UX design will know. Often the people themselves can't articulate the pain points. They
Hmm.
just get sort of like vaguely annoyed in certain situations, and you have to suss out what the problem is. So we
Yeah.
do a lot of that. What are the specific pain points? And then what are we, Million Concepts, sort of uniquely positioned to help with in the maximum possible way?
Hmm.
And at that point, we execute. It worked that way for Perseverance. I'll say, to toot our own horn, which is part of what I'm here for, so that should be fine. We joined the project, I think, a week or two before landing. I forget
Hmm.
exactly. Sort of early on, we recognized that there was a gap. There was a tool gap
Mm.
in the way that all of this multispectral data was coming down. It was being processed by people, and then they were just sort of throwing it onto a wiki or onto a
Mm.
shared Google Drive.
Hmm.
And there was no sort of ongoing management of the data. There was no monitoring of like who's doing what to prevent duplicated effort. And it was just, we had a similar instrument on Spirit and Opportunity, and these were legacy systems, and Spirit and Opportunity were 28 years ago.
Hmm.
Um, so it was just sort of until we were in the trenches of this project, no one realized how much data this was going to be, also in compared to previous missions. So Curiosity had a
Mm.
similar camera, but early in the mission, there was a much slower flow of the multispectral data. It was something you could actually manage manually.
Hmm.
So we recognized that this was a problem, that it was burning up a lot of time, that there were even manual processes where like the different views of the data, so you might have different band maps for different
Hmm.
image sequences. Those were being produced manually, with software that I helped write in 2002, still, and by grad students, and it was taking a lot of time. And that's just sort of how it had always been done. So we recognized all of this as a big problem and something we wanted to fix, but also we knew we had to fix it quickly
Hmm.
because, like I said, those first sort of 4 to 6 weeks of any new mission are when things change rapidly, and then they get sort of calcified into a routine.
Yeah.
Um,
This is kind of the scientific version of no battle plan survives contact with the enemy, no research plan survives contact with the destination.
yeah, yeah. Um, so here's to the horn tooting. I think we joined 2 weeks before the mission. We recognized this sort of almost immediately once we saw the team working in the actual environment of the mission. We developed our MVP prototype, I think by week 3, and we had a fully deployed system by week 6, which still operates today. We've done we bought down technical debt, we added documentation, we've done all of those things that you do, but now it operates basically without intervention, and it manages all of the multispectral data. When new images come down, all of those views on the data I was talking about that were taking grad students hours and hours to develop, all of those are done sort of automatically. You still have humans in the loop for critical parts of it. And all of it flows into this shared spreadsheet
Ah.
Google Docs that all of the scientists can go look at, and they can all look at the same data, and they know I'm pointing at this spectrum in this observation. They all know exactly what that is.
Mhm.
Um, and it runs basically without our intervention at this point.
Nice.
Um, so
Just
so
one point of
I'm very
curiosity.
proud of
Yeah, absolutely. A
that.
technical curiosity is it
Yeah.
a custom data store databasing that it's going into, or is it like going to Zenodo or some sort of public archive? How's it stored?
Yeah. So there the I'll explain the chain of data custody. That's fun. Um, so the rover driver, who is a person who types commands into a machine that then gets uploaded to the rover, because they're not using a joystick on Perseverance, will receives command sequences from the mission teams, including the MassCamZ team, and the MassCamZ team will say, this is the multispectral observation we want to collect. And then they put that into whatever code it is that the rover can read, and they send it up to the rover. The rover executes, and then the data sits on the rover. Eventually the data comes down, but you have limited control over when and what order the data comes down, because there are a lot of competing priorities for the pipe. So we might get one image if it's a 12 image multispectral sequence, we might get one image, and then 3 days later we'll get 3 images, and the calibration calibration targets, which we need to do the radiance calibration, might come down a while later. So there's a lot of uncertainty in what data you will have at any one time. So when you're running your data analysis, you have to assume, oh, we might get more data from this observation later, we're going to have to reprocess it. So as that data comes down, it goes to JPL, and then it goes to a server at ASU where we collect it. The team does analyses on those data. So in the case of multispectrals, they select what they call regions of interest, which are parts of the image that they want to extract spectra from. And then our software runs on the region of interest files and on the data files.
Okay.
Something I've been passionate about for 20 years, and that we take as sort of a first line commandment at Million Concepts, is reproducibility of your scientific analysis. So we wanted to make sure that every time someone ran our software, that we would be able to recreate that analysis at the point that it was created. So as such, every time our software tool is written, it's called ASDF, Archive Spectral Data Function. So they do a key smash, and it runs this data. It archives the data in 3 places. We archive it. First of all, there's a AWS archive, which we glacier periodically, to keep our bill down. It also goes, a limited subset of the data goes to Google Drive as a backup, and then there's a local backup on the computer too, on the server at ASU. And the database of like what data is available is actually the file system itself, which is sort of just legacy
Okay.
of how these projects have worked. We do have, for QA purposes, our own like SQL, but the volume of data is so small that you just run on the file system itself, and it's very quickly to mine through the whole file system. And then on the Google Sheets, we have, through the Google API, we're uploading all of that data to Google Sheets, and it all gets into the spreadsheet, and which database as well.
Okay. Very nice. Um, you mentioned UX, and that was
Yeah,
something, even from early on when you were talking, that came to mind, is that it seems like um a lot of what you're describing in terms of the ethnography and it's like UX, but it's several levels deeper. It's not just the person who happens to be in front of a console interacting with something, how how they
yeah,
are going to interact with your tool. And this makes a lot of how is the team going to use it? How is, what are it makes a lot of sense. I don't actually know. I've not thought directly at it about that kind of
yeah.
need structure. Um, how I'm assuming the answer is yes. how does that apply outside of the comparison being the Yelp or the Airbnb,
Mhm.
those kinds of enterprise applications. Do you have experience with applying these sorts of broader user and team interface principles to those sorts of other contexts? Right.
Yeah, so the field that we're drawing on there, so like it's ethnography, but
Mhm.
more specifically, it's the field of human and computer interaction.
Okay.
Um, and I got direct exposure to this on MER when the ethnographer Janet Vertesi did her graduate project studying the mission team. Um,
Ah.
and she wrote a book called Seeing Like a Rover, which is required reading for everyone in my organization, and recommended reading for everyone. As academic, um, as the book coming out of a PhD program goes, it is an incredibly well written, readable book that I have read multiple times. So this human computer action and ethnography of project teams around technology is the sort of broad field that we're drawing on. And there are a lot of people doing that work specifically. But I think I'm sure other people have a similar approach to us, but something we value highly and something I think is part of our value add is that we really think about that sort of stuff right away.
Mm.
Like long before we start thinking about technical things, we start thinking about what is the social, technical, historical, financial, economic content, what is the full context
Hmm.
um, in which this problem exists and in which the solution must exist.
Hmm.
Um, so while again, most of our work has been in space, so most of our work on this has been in space stuff, don't have much experience. Um,
I
in
realized I asked the wrong question.
yeah,
I was meaning to ask that it's relevant to other projects, not that you Million
yeah,
Concepts had
yeah,
expertise there.
and
So apologies.
yeah, and so this field is in all sorts of is deploy anywhere that people are doing things. There are ethnographers looking at how they're doing things and doing sort of critical analysis of that. I know there's I'll get it wrong if I state specifics, so I won't. But I know a few other ethnographers who I've talked to who've done sort of consulting arrangements for big companies. Like maybe you're an airline and you want to know how to get people through your check-in counter line more efficiently.
Mm,
So you could hire an engineer to do that, but you may also want to hire an ethnographer who's not, it's they're not going to like interview everyone and make a bullet pointed list, but they're going to tell you what are the broader trends around why you're getting bottlenecks at this certain point, or what maybe sort of point out other places that you may want to pay attention to.
mm,
Um, those people are generally not also in a position to implement the technical solution
mhm,
once they've identified those things. And your technical people are also not generally in a position to recognize the changing landscape in which the problem and solution may exist, and to adapt to it as it changes. So, for example, when we deployed for Perseverance, we deployed ASDF very early in the mission. Things were moving very quickly. We knew in that context, if we produced anything that was slightly buggy, slightly annoying, interfered with existing flows, demanded extra time up front, even if it would save time long term. We
mhm,
knew any of those things just in the, just understanding human psychology, first of all, but also the pressure that people are under in that stage of the mission. We knew any of those things would kill the project immediately.
mhm,
So we had to design a system that would not just solve the problem, but could be inserted into the existing workflow in a way that would be socially acceptable, also scientifically acceptable. The scientists, another thing that will kill it immediately is if the scientists don't trust it.
mhm.
Um,
Yeah.
so But then once there, so you build, there's the conditions that exist before you build the system, and then you build the system and you insert it and you sort of nudge the system. So that's actually a different system you're operating in at that point because you've modified it. And
Hmm.
then once the system is in place and it's working, and it's what ethnographers of science call a fact, which is that people have forgotten that it ever didn't exist that way. They
Right.
have forgotten that it's even a notable technology. And we're at that point now. We have grad students who are coming onto the project who never knew that this thing didn't exist. That's an entirely different cultural ethnographic situation, and you have to deal with that differently.
Hmm.
So at every phase, you have to recognize how all those things are changing, how your approach to technical solutions has to change. And many, I keep saying technical solutions, but many of the problems are not technical solutions, they're social solutions
Hmm.
to technical problems.
And there, in any given technical problem, there are a multitude of ways to solve it. But if you don't choose one that dovetails with the social, everything you've been saying with the social context, then it's not going to be successful, or it's going to struggle at least.
Yeah, and I mean, it could even be worse. It could be net negative.
Harmful.
If you
Yeah.
if
Yeah.
you have a perfect technical solution deployed incorrectly,
Hmm.
um, then it could be, you could kill everyone's productivity. You
Hmm.
could that's certainly something when we come onto new teams. I assume everyone experiences this. When you come onto a new team, especially if you're eager and you're sort of there to like solve some problems and shake some things up, people get very nervous, which is absolutely reasonable,
Hmm.
especially if they don't have a track record with you. They don't know that we are very, very careful to not break things.
Hmm.
Um, if you have someone who comes in there who does not share that care, and they only want to solve the technical problem, and they're not so much worried about their attitude is sort of, well, you're doing it wrong, so you're going to do it right now,
Hmm.
instead of an attitude of, um,
Let's
okay,
work together, you know.
yeah, you've been doing it this way for 20 years. I understand. Like, it obviously works for you. I would
Yeah.
like it to work better, because your time is very valuable to me. Um, if you come into it with the wrong attitude, then it will be a net negative, even if you've come up with a correct technical solution.
Mhm. Sort of along those lines, in the coming in cold. There's I'm seeing it. I'm wondering if there's if you. I'm thinking that there could be a bit of a paradox to the role of coming into a project. So, like with Viper, you've been there from early on. With Perseverance, you came in a bit later.
Yeah.
In a context where you're coming into an established situation, on the one hand, there's the value of a new perspective, fresh eyes on a situation, on a problem. Let someone without all sorts of assumptions and baked in, this is how things are, can potentially identify solutions and things to change or problems that are everyone else is blind to. On the other hand, when you're coming in fresh to something, you don't have any context. You have to learn that context.
Yeah.
Um, it, how has that paradox played out for Vermilion concepts in the past? Like, I would think as long as you're aware of both of them, then you can navigate reasonably well. But I don't know. What's some thoughts on that?
Um, yeah, that is tough. Um, I've definitely we've failed at that.
It's
Um,
hard. I mean, like
in
it's
and I don't think, not because I'm protecting my own ego, but for other reasons, I don't think I can go into the situations in which I failed. But I have failed at that sometimes badly. It's usually in the context of um, either of something um, scientists spend a lot of time thinking about stepping on toes. Like even though everyone's supposed to sort of
it's a
push
it's a it,
push
it's a
back on everyone else's research, there is a sort of sense
yeah.
in science that like people have their own little specific domain, and like that's Bob's expertise. Whatever's happening in that magisteria is
Mm,
Bob's.
hmm.
You don't mess with Bob's magisteria. And if you
Right.
don't have that topology going into the project, then it's very easy to upset Bob, and Bob might have a lot of authority. And even if Bob is not, sort of going to be actively hostile about it, like Bob will harbor bad feelings if
Hmm.
you come to the project and you look around, you say, well, that's wrong, and you're pointing right at Bob.
Right.
So we do have to manage that. I've gotten better at it as I've gotten older. But another thing that we try to do is when we pick our client, I'll say. So there are people who've come to me and asked me to work for them, and I was like, I don't think we're gonna,
Be a good fit.
yeah.
Hmm.
So when I pick my clients, I try to pick people who are gonna understand that that I sort of expect them to protect us a little bit, like
Hmm.
not from our worst excesses if we do those, but I said this to a colleague when I joined Perseverance, which is I don't have time to understand the political situation here. Like
Hmm.
I don't know. There's a political situation because there's a group of humans. I'm not like the fact of a political situation is not a demerit, but there's a political situation. I don't have time
Yeah.
to learn it.
Right.
I also don't have time to learn the sort of cultural shibboleths. I don't, and the niceties. I'm gonna annoy someone because we have to move quickly if we're gonna do anything.
Hmm.
Um, so please, when I start to step over the line, please let me know so that we can address it.
Right.
Um, and that worked well on that project. And with Viper, we're a little more peripheral. So it hasn't come up, but it's sort of a similar thing. It's like, I rely on our client, who is our contact to the organization, to let us know, to provide a little bit of a filter on us to make sure that we're not oh, sorry, I was distracted by chat, to make sure we're not uh running aground, upsetting anyone necessarily.
Hmm.
We're
So, I
also
mean,
we're just, there are times when we're going to upset people, um, which we also have to accept, and we have to pick those battles, because there are going to be times, and there have been times when we get digging into something, a pre-existing solution, and we find something that was wrong, which is also just a fact of the human condition. It doesn't mean it, even though if all scientists understand intellectually that they are wrong about everything all the time, there's nonetheless egos involved. And when you find that something someone has been doing for years and years is wrong, they will have bad feelings about that.
Mhm.
Um, so we, but also we have a commitment to making them more right. Um, that's, I refer to it as our fiduciary commitment to our clients,
Mhm.
which is that we are going to make them look good. Um, so, which means making them more right. So we do have to pick those fights, and there have been a few times when we had to, like, really push on something, like, I know this is uncomfortable for everyone, but we're gonna make this right.
Indeed. Um, any so we've talked about, you've talked about the people side, the politics side, the ethnographic side.
Yeah.
Is there
We've talked
anything
almost nothing about managing data, and I'm sorry, but
that's okay? It's been extremely interesting, and I think it may well be a perspective that a lot of clients, a lot of consultants, maybe they sort of know on a gut level that they need to be concerned about, but don't think about it consciously, don't specifically make it a focus. Um, and that's kind of important to call out. Um, is there anything, just to return to the technical briefly,
yeah.
anything, any interesting tidbits, specific interesting challenges, Viper being the kind of the reference case that we were going to be talking about. Anything technically there interesting that you can share, that particular challenges to overcome, how it ties into the hostess, uh, kind of open technical question there.
Um, so like I said, we did this trade study on what we're calling the orchestrator system.
Hmm.
And we can set, Airflow and Dagster were at the top of our list initially. I think by the end of it, I have the list up here somewhere. I think we reviewed 200 different packages,
Oh, wow.
all over anything we could find. We found a list of like acyclic graph managers. So we reviewed all these packages on GitHub. Most of them are open source, even a few commercial packages.
Mhm.
We eliminated, I'm just reading off my notes now. We eliminated 160 of them,
Oh, wow.
almost out of course, for the reasons that people who use open source will be familiar with, and for people who do searches on GitHub, which is that a lot of them on the boilerplate in the readme.md had all these grand visions for what this project would be able to do. And maybe in many cases, the project creator got the project to the point where it did the thing they needed specifically, but it
Mm.
didn't do most of what was on the 10. And it also lacked, for our purposes, we needed good documentation, we needed test coverage, we needed robustness. These are
Mhm.
things like Airflow and Dexter offer. Then we got it down eventually to 9 options and ended up just knocking them off the list one after another until after. So we started with the idea that we'd have Airflow and Dexter, and then we reviewed 200 and got them down to 9, and then we started knocking them off for different little infractions, like it didn't quite hit our philosophy of how this sort of thing should be done. And then
Mhm.
we got it back down to Apache and Dagster were the final two. Which we then, we seriously thought about. We're conscious of the not invented here phenomenon, so we don't want to reject an external solution just because we didn't build it.
Mhm.
But there's a flip side to that, which can also be a problem, which is that not invented there phenomenon, which is the belief that because someone else built it, it must be better, which is also can also be a pitfall in both of those cases. So we really thought about Apache and Dagster and what we needed, and they are incredibly powerful, extensible, robust tools that are about 3 orders of magnitude more than what we need for the problem that we have. And then on the other end of that, we thought, okay, well, what do we actually need to do? So we need to we get the signal that data has arrived. We need to put the data in a place. We need to kick off various sub-processes that run different modules. We need to get some sort of signal when those are done and stage the data properly and put entries into a database, blah, blah, blah. We could do all of this with the cron job.
Mhm.
Like that's the other end of it, is like the old school Linux tools are for
Work.
this.
Yeah.
And we seriously considered that. And then thinking a little bit more, we'll have to manage this. We need it to be extensible, or we need it to be adjustable quickly once the mission lands. We might only have SSH access into the server. That's when we decided that we needed some sort of solution between those two things.
Mhm.
So it's not a problem. This scale of thing, like we can solve it with a cron job, is not a problem that Airbnb has when managing their bookings.
Yeah. Yeah.
I'm sure they have plenty of cron jobs, but it was in this liminal space between like the most basic possible tools and the enterprise tools that everyone thinks about immediately.
Mhm.
And neither of those were really the correct solution for the problem that we had.
Mhm.
I suspect that this sort of liminal space problem is extremely common across all industries and software deployments. And often people will, for reasons of ethnography, people will gravitate towards, here's this simple solution, it's just cron jobs, it's fine, it's free, everyone understands it. We'll
Mhm.
gravitate towards that, even though it's not exactly right.
Mhm.
Or here's Apache Airflow, we can get a support contract for this, ongoing support for Apache Airflow. okay, maybe none of our team really understands it, but we'll have this external consultant. It can absolutely do everything we want. There's no question about that. It's just a
Hmm.
matter of how complicated it's going to be. But also we're going to be sort of like, once we've deployed that, we're going to sort of be locked into it because it's so big and complicated. It's going to be a big push for us.
Right.
So we're going to do that because it's safe. It's what everyone's doing, and we can get a support contract for it.
Right.
But it's also not exactly the right solution. And I
Hmm.
think almost everything, almost every problem for every organization falls between managing bookings for Airbnb and and doing daily backups on a cron job. And yet, after reviewing 200 different possible options across GitHub and commercial offerings, we could not find one that filled that space, which is why we sort of had to build it.
Yeah.
And it's available. It's all open source. This is a NASA policy now. We're developing in the open. It's not. I wouldn't say it's ready for everyone to use yet, but it's a
Mm.
good tool, and we intend to keep building it out. And it was just really notable, unexpected to us that there was not a solution already in between those two things that we could just use. It was a big surprise. Like we double and triple checked ourselves that we weren't just missing something.
Yeah. I mean, speaking from direct personal experience, I mean, that it's not just in, developed, software development, tools that happens. And we're running into it internally, just simply, lightweight project management is like
Mhm.
everything tends to devolve back to a Google Sheet because all of the more complex, fully featured tools, the handle's just a little bit the wrong shape, and it's like, well, no, this is awkward, and it's, I need this
I,
feature, but it behaves this way, and yeah.
exactly that problem. I went down a rabbit hole like 4 months ago
Hmm.
because I was like, oh, maybe I should start using. I've been doing everything in Google Sheets. It's fine for the scale of projects. We're
Monday or
fine. It
Trello
works.
or yeah.
Um, and my team is small, and the projects on enterprise scales that we tend to work on are small. And I'm not managing 30 vendors or something. So
Hmm.
Google Sheets works fine. I was like, but maybe it's time for me to get into a more full-featured project management ecosystem. So I looked at multiple, and all of them were like 60% right.
Yeah.
And then that 40% was going to eat up like the amount that the 60% saved me, the 40% was going to eat up 10 times as much time in me
Hmm.
like working around it.
Hmm.
Um,
Yeah, 20 clicks to do one
yeah.
thing that, yeah.
Another place this happens is accounting systems. If you've ever, so
Interesting. Okay.
these like enterprise accounting systems. I won't name names, but there are sort of three that anyone who does accounting will think of
Hmm.
immediately. Um, they will do everything, anything you want, and I'm sure this serves their sales pipeline well, because they can do anything.
Yeah.
If the person making the purchasing decision says, can you do this, they can say yes, and they're correct. They will do anything. But also in the course, they do everything. And it is, if you are not on a service contract with someone who knows how to make the system do exactly the thing you need to do, then you personally will never figure it out.
Hmm.
Um, and because it's like it's anti the Python mentality of there should be one right way to do everything,
Yeah.
which used to be true of Python. The the sorry, that was an unnecessary dig, but
That's okay.
there's a lot of ways to do things in Python, which it
There are
makes it
now.
powerful.
Yeah.
Um, the uh, because there's so many ways to do everything, that means sort of everyone who has the same problem has a different solution to it.
Hmm.
So if you're going from this organization to this organization, they have basically the same invoicing workflow or whatever. There's going to be a different approach to it, even though they have the same endpoint.
Yeah.
Um, these sorts of things drive me a little bit
Hmm.
uh, nutty.
No, I have some direct experience with one of those big name accounting programs. I did a little bit of volunteer bookkeeping work, and every other week there'd be one transaction. It's like, oh, I need to book this way. and it is not obvious how I'm supposed to do
Mm.
that with this, because like, oh, if I flag it this way, then it doesn't show up over here. No. Yeah, so
Mhm.
I feel that. All right, well, we've hit the top of the hour. Should probably
Okay,
wrap there.
right.
That's all for today. Thank you, Chase. Really
Thank
appreciate
you.
your input and your time. Thanks to the attendees. Like I said, we're recording it. I'll get the video up on OpenTeams YouTube as soon as we can. Please check out openteams.com to learn more about Open Teams and our offerings, and we'll see you next time. Thank you.